Hi, in this video we're going to have a look at this motor. It's a reasonably common motor. It's a Brook Crompton Parkinson motor. It's probably a little bit vintage, not terribly so, and I think it's probably something like about, what's it say there? I think 550 watts, I think it might say, so 3/4 horsepower then in that case. 1425 RPM, so that's a 4-pole motor. You'll see it's got one capacitor there that I believe is going to mean that it is a start capacitor, so it's going to have two windings. One's going to be the start winding and one's going to be the run winding, and we'll be able to establish that in this video. So what I'm going to do in this video then is we're going to look at everything on this motor. We're not actually going to disassemble the motor. The only disassembly that we're going to do, or that I've already done, is just remove the connection plate. Okay, by the way, often these connection plates actually have the details of the wiring inside. This one rather unhelpfully doesn't, and when it came to me it was I'm pretty confident it was miswired. So we're going to go through, have a look at all of these connections, and by testing we're going to get it working. We'll see if we can get it so we can reverse the direction as well, and also we might even try to wire it incorrectly and see what the implications of that might be as well. So this video might drag on a little bit. It's not going to be a quick one. I do, however, hope it's useful. And by the way, if the videoing quality isn't great, sorry about that, but I'm trying to do this with a mobile phone. So let me just prop that up there. Okay, so if we look in the connection plate, and I'm actually going to, or I have already drawn this out, so we can look if it's not clear enough here. But there's 5 terminals here, and this one is labelled AZ, this one's labelled A, and then we've got Z, this one says S, and then this one says T down here. Okay, now there's also a K up there, and there's nothing, there's not even a binding post up there. You'll find other motors that are quite similar to this, quite possibly another Brook Crompton motor, that although it might have, I think they often use this same connection plate, but then they don't have all of these binding posts. Quite often you might just see like 2 or 4 of them populated. Anyway, that's what we've got. What I'm going to be doing, just to make things a little bit easier, because I'm going to be reconfiguring, I'm actually going to add some wires to these posts, and then we can quickly change things around rather than just keep on, messing around with those binding posts, which I don't really like to do anyway, because there's always a risk of damaging something there. So we just put stuff on, and then we can do the testing a little bit more remotely. Okay, so what I've done with these wires, I've labelled them up. Okay, so you'll see like I've got A there, and so let's just pop that on. I'm going to try not to bash my fingers. So I'm just going to, yeah, it's not great, is it? I'm just trying to put the brush there just to angle it up a little bit. Hopefully it makes it fairly easy for you to see what I'm doing. Now, in fact, let's just pop that out again. I've got a few of these. There is not a complete set, but some of these came with it. So normally you should have like, one wire on there and a nut, and then these. In fact, I say that I've got another motor, a more modern motor, and it says don't do that. Don't separate them with the nuts. That they should, all of the crimp terminals should be positioned together, but presumably to reduce the resistance. I'm not, to be honest, I'm not too bothered in this particular case. So let's just double check that I've got A there. Yeah, I've got A. So if you're not familiar with one of these nut drivers, I recommend, if you're playing around with motors, to get one of these. They're really inconvenient, to be honest, these nuts. It's 2BA. I wish it were metric. Actually, I believe that BA is actually metric sized. I could be wrong on that, but it's sort of old anyway. So let's get that in there. Okay, so that's 8. Let's see if I can find my wire that's labelled AZ. So there we are. Now, I'd be lying to you if I said that I've no experience of wiring these up, or no knowledge of what it's likely to be wiring wise. So, you know, I think that these two, these A and AZ, the ones on the left, are actually going to be drum winding, and we will confirm that in a little bit. Okay, so I don't want to make out that I'm like just discovering stuff brand new without some prior knowledge. Try not to drop a washer there in the motor. I mean, if you do, get it out before you start the thing. If you don't have one of these nut drivers, it's a little bit tricky sometimes trying to get those nuts done up. By the way, you know, I wouldn't really be advising using cable like this, and they're all going to be the same colours. Probably not great, but just for our testing purposes, because that's all I'm going to do. It will be fine. So I've got T there. Where's T? T is the bottom one there, bottom right. So there we go. Let's put that there. I'm pretty sure when I took these nuts off that one of the nuts, unhelpfully, was a very slightly different size to the others. So I've got another nut driver to hand if I need it, which I think I do in a while. Okay, so I'm just snugging those up. We've got S just there on the right. So let's just see if I've got one of those. I don't actually know what you call them. These like little washer things, little cup washer type things. I don't, to be honest, I don't actually think they serve any purpose in this case because I've already crimped the wires. But if the wires weren't crimped like this, then it might be useful. There's also, in these old motors, there's often something that looks a little bit like it's like a ring crimp type thing. It hasn't got like this plastic body. It's just like a little ring. Bit difficult to describe, to be honest. Often see those in the older motors. And so there's one more wire which I was just looking around for, but I left it elsewhere. So that's Z. Okay, Z is top right. And I'm just going to stick a plain washer there. That's all I've got. Okay. And by the look of it, this is the one where the nut is same thread, but slightly different size across flats, peculiarly. There we go. Okay, so change the nut driver. This one, can't read what this says. This is a little bit rusty. 8mm possibly. Okay, so we got all those. So we got 5 binding posts, 5 labelled wires now. And then also, of course, we've got the earth. So the earth is screwed onto the frame there. And also, notice this is what we call a resilient mount motor. So there's like a rubber ring here. So to make sure that the mounting plate there, the foot is in electrical contact with the body of the motor, then you've got the additional earth there. So what I'm going to do is I'm going to use these. They're either Wago or they're Wago Ripoffs, but they're one or the other. I'm just going to clip one of those onto the end of each of these. That's going to be important later on when we actually run the motor, and we don't want to have like and we might like partly wire it up. We don't want exposed wires, and we can also put the multimeter test leads in there too. I've no idea if you can hear me correctly. I'm going to probably find by the end of recording this video that there's some technical problem. I can hear quite heavy rain outside. I doubt you're picking that up. But... Right, okay, so that's what I got so far. Okay, now let's just have a look at this. So these are the motor terminals. So we got AZ, A, Z, S and T. Now I believe that these are the run windings, or they are the connections to the run winding. So that will be a good one to start with. And because there's 5 terminals, I believe that there shouldn't, if they are the run winding, they shouldn't be connected to anything else actually. Now this is an auto ranging multimeter, which actually doesn't make it particularly easy, to be honest. It'd probably be easier with an analog meter, but AZ and A, that's what I reckon. Those 2 left ones, I reckon they're the run winding. So we got Z, sorry, not Z, AZ. Okay, so AZ, so let's just pop that in there. We're going to check continuity. Okay, so AZ, which is top left, and then A bottom left. So let's see if we can find A. And I'm expecting a fairly low resistance. Let's see what we got. Yeah, we got 4.3 ohms. Okay, so bearing in mind, I believe that is the run winding. Let's commit ourselves for the moment, unless we find otherwise. That is the run winding. And what do we got? 4.3 ohms. Okay. I don't think we need to worry about the decimal there, but I'll just put it in anyway. Okay. Now, if that's the run winding, there shouldn't be any continuity with any of the other terminals. So what I'll do, I'll leave the test probe into AZ, and then I'll just probe Z, S, and T. So I said I'd leave it in AZ, so that's AZ. So I'll leave that one in, and I'll pop it out from A. And then I believe that there should be no continuity with the others. Well, actually, what I'm going to do, I'm just going to quickly check here. So nothing, nothing, and nothing. Okay, remember, if we go down there, then that's the 4.3 ohms. Okay, hopefully you can see that fairly clearly. Okay, so that had no continuity with those. And if this one had continuity with any of them, then we would have actually had a reading there as well. So we don't need to go off that and then check those ones. Right, so I believe that's the run winding. I also believe that this is going to be the start winding. Now, the run winding normally has quite a lot lower resistance than the start winding. So let's just see if I'm correct in thinking that S and T are the start winding. So pop that out of there, looking for S. Obviously you could be playing around in there, but it's to be honest, so much easier doing it like this. Much my preferred. So that's in S. Okay, and then I said that T, let's see if we can find T. Oh, T's in my hand actually. Okay, so I'm expecting a resistance that's maybe something like 20 ohms or something like that. 14 ohms. Okay, so 14.4. So let's just add that to here. Okay, now so we've got a start winding. Now I believe there's going to be a centrifugal switch either somewhere here or somewhere up here. So but at the moment the switch is actually closed, so we won't be able to find that, discover that until we actually make the motor run. But there's start winding. So there's something up there, and I believe that will be the capacitor. So let's see if we can figure that one out. So what you're going to find is that if you put the multimeter, and once again it's best done on an analog meter, but if you put the multimeter across those 2 terminals, if it is capacitor, it's going to rise up. And in fact we can even charge it up, and I've you know, so we can try that. I've got a battery there as well, so, or a battery pack. Let's just see what sort of reading we get, if any. So we want, I've probably just disconnected the wrong one there. S and Z, okay. Let's have a look at S and Z. So there's Z. And then we're looking for Z. Find it eventually. It's got to be one of these somewhere. Oh, I got Z. Sorry, I thought that was S. Let's get S. Okay, so what I'm expecting then, assuming that there's no charge on that capacitor, and there really shouldn't be, then I would expect that the resistance is going to increase. Basically the multimeter is going to be charging up the capacitor. So what we got? Nothing there at the moment. That's interesting. Oh, there we go. That's strange, isn't it? Okay, so you'll see that the resistance is changing. Now, when the resistance changes, typically that's going to be an issue of trying to measure across a capacitor. So, easy way to do this now is just to see, well, first of all, let's just see if we, if we go on to voltage reading, and let's just see if there is a voltage on that capacitor, if there is a capacitor. Now, just to make things easy again, let's just try, once again, we try on these leads that we've got on here. So that one is Z, and then we've got S. And it's going to make it easier for me if I can do it like this. So at the moment, there is a very small voltage on there, and you'll see that that voltage is falling. So we have further evidence that it probably is a capacitor there. Okay, it probably has been charged up, and now it's either self-discharging or very, very slowly discharging through the meter itself. Okay, so what we could do, perhaps, we could try charging that capacitor up. Now, it's mains rated capacitor, AC rated, so we don't have to worry about the polarity. And what I've just got a little battery pack there, 4 AA batteries, and a little battery connector as well. So this might not be like the way to test a capacitor, but it's going to just prove a point that there is a capacitor in there. That's all I'm after, really. Not trying to be too scientific about this or anything. Obviously, I wouldn't leave this battery pack connected if I were running the motor. I think that hopefully that goes without saying. At the moment, the battery is not connected. When I connect the battery pack, by the way, I think these are 1.2 volts each because they're not alkaline batteries. So we're looking about roughly about 4.8 volts, something like that. So that should go up to 4.8. Remember, there's no series resistance here. It's just the resistance of the battery pack itself, plus a little bit in the wires and the capacitor. So it should go up fairly quickly. Okay, so we basically charged it up. The polarity is around the, it shows negative polarity. That's just the way I've connected the battery. That's nothing to worry about. Okay, so showing the voltage of the battery. Now, if I disconnect the battery, if there's a capacitor there, then it should be holding that voltage. And yeah, it's slowly discharging as one might expect. Okay, so I'm fairly confident now that we can say we've got a capacitor there. Okay. So I think we didn't write down that resistance, but I think that was 14.4 ohms. Let's say it was 14.4. I might be off, but I think that was what it was. Okay, so this one is the run winding. This winding is the start, And somewhere there's going to be a centrifugal switch. You know, it might be, you know, up here, it might be down there. Okay, we don't know that for the moment. See if we can figure that one out. Now, the reason why it has a run winding and a start winding is with this start winding arrangement, there's actually a phase shift in the AC signal, so there's an offset, and so you can get predictable start. Well, you can start the motor up, and also you can start up in a predictable direction. So you need this secondary winding to actually get the motor started, unless you're able to physically spin the motor up and then apply power to the run winding. But if you apply power just to the run winding when it's stationary, it's not going to start up. And in fact, shall we even try that? But when in doing that, don't really recommend it. It's not good for the motor. We just blip the power on momentarily because you'd actually just probably burn out the winding if you left it powered up and not turning. So let's just get that out of the way for the moment. And so we want to connect up A and AZ to power. Okay, somewhere. Yep, here. I've got more of these. I love these things. They just make the wiring so easy. So all I've got there is cable terminated with that. Obviously that is intrinsically dangerous to leave that lying around if you've got kids or anything like that, or anyone actually. I mean, it would be really very, very easy to plug that in and then electrocute yourself, so do be careful if you do this. And then we need earth, so let's get the earth connected. So I've got my, that's coming from the mains lead, the red lead, and then I need to connect that to the earth. Okay, so I've got my earth. And then we need A and AZ. So we've got A, and that's T, don't want that. A and AZ. Okay, now it shouldn't make any difference as to whether we connect A or AZ to the to live or neutral, which way round, you know, doesn't matter. Shall we'll just note down just to so we know what we're doing, what we're going to do though. We'll have live up here and we'll have neutral down there, but it's not going to make any difference. Okay, no, it shouldn't make any difference anyway. So live on AZ, which is brown, UK wiring colours of course, and then blue on A. Okay, now if I were to plug that in, as I say, we haven't got the capacitor, or I'm going to need to put a block on that. We haven't got the capacitor, we haven't got the start winding connected, so it really shouldn't run. I'm going to blip the power on momentarily. Hopefully you can see the spindle there. In fact, what I'll do, sorry, while I get a bit far away, I'll just stick a bit of tape on the spindle and it might be a little bit easier for you to see it spinning or not spinning. I think it's probably going to judder, would be my guess. Okay, don't do this often. Okay, so just going to plug it in, and I'm just going to put it on just for like a split second. It did, yeah, but it's not wanting to start properly. Okay, I really don't like to do it any longer than that. Don't want to overheat the run winding. It's certainly not starting up quickly like you would normally expect. However, if we were to spin this and then to apply the power, should work. So in fact, I'll just plug that back in, and then I've got this cord here. Now you want to be quite careful about this if you try something like this, because you don't want to get the cord wrapped around your hand and then the motor starts, and then to pull your hand back in. So I'm just going to give it like a dry run just to show you how I'm going to do this first. I'm just going to go like this. And then once it's spinning and I'm well away from it, then I'm going to apply the power. Okay, so that's the plan. So remember, this is going to give me the start because we don't have the start winding. So pull that and then power on, and now it's running. Okay, so all we've got connected at the moment is just the run winding. The start winding is not in there, but that's actually the case. I mean, normally once the motor has started, the start winding won't be used. It's a single phase motor, it's not a dual phase motor. When it slows down, you'll hear there, maybe you heard it, maybe not, centrifugal switch just click. Okay, I'm just going to stop there for a moment because I think my phone's filling up on the video, so I'm going to transfer and then transfer to my computer, and then we're going to have a look at the rest of the wiring. We're going to figure out where that centrifugal switch is. Yeah, there's loads more stuff that we can do. Yeah, okay, so part 2 coming shortly. What we've done so far then is that we've established that that's the run winding. We've taken a measurement. We know that there is another winding here, the start winding, and there's a capacitor up there. So what I'd like to do now is to have a little bit more of an investigation there. So I'd like to know, is the centrifugal switch somewhere between S and T? Now, we won't know whether it's before or after this winding. We're not going to start taking the motor apart fully, but yeah, I'm sure we can figure that one out. So just to assure you that I have unplugged it, and I'm just going to pop that lead out for the moment, actually. And I'm going to put it somewhere where I can't, like if I get sidetracked by something, let's say if I were to quit this evening and then come back and then accidentally plug something in, I want to put that lead somewhere where it's safe to me. Okay, so that's all we've got at the moment. And what I think we can do is we can, this is quite low resistance, so what we can do, we can connect a battery up. So we'll have, in series with this winding, we'll have a light bulb, a lamp, and we'll have a battery, so just DC, and then we'll just basically light that lamp up. And then if we spin the main rotor, if we spin that rotor, then if we can spin it fast enough so the centrifugal switch opens up, then that lamp should go off. So that will confirm that the centrifugal switch is there. Okay, so that's what we're going to do. And I've got a lamp. It's this, okay. I think it's probably, let's see, I can't quite make it out. I think it's 3.5 volt lamp. That's going to do, okay. Possibly not ideal. I haven't done any calculations, but it will be fine. Anyway, so let's put that on T. So just to remind you, just to remind myself, T is the bottom one. Okay. So there you go. That's T. So remember, what we're doing here is we just want to confirm where that centrifugal switch is. Right, okay, and let's pop another one of these in here. This will allow me to connect my battery. Remember, we haven't got any mains connected to this at all. And then we need to connect that to up to S. Okay, so the battery is going to be on S, which is that one. Like so. Okay, so let's just sketch that out just to make it absolutely clear. So all I'm doing is I put the lamp down here, didn't I? So lamps there. Okay, and then I've got a battery here. Not sure which way the polarity was. It's not going to make any difference anyway. Okay, so I don't know whether you can see that. I've done it intentionally lightly. So there we go. Lamp, battery, in series with that winding. Okay, and there's going to be a switch in there somewhere. So if I connect the battery, I'm expecting that lamp to come on. Maybe not brightly, but it should come on. Yep. Okay, so that lamp is on. Hopefully you can see that. And if I turn the rotor, I'm expecting, yeah, it flickers a little bit, but it's still on. Okay, now if I can get that rotor to spin fast enough, that should open the switch. So shall we see if we can do that? So I put a knot there. This does have a keyway in it, so it's quite handy to do it like that. And like I said earlier, I would be very, very careful doing this when it's under power, but this is just like totally not powered. So if I can spin this fast enough, then the switch should open and the lamp should go off. Let's try this. Yeah, and then hopefully we'll hear the centrifugal switch click. There. Okay. Hopefully that proves it. Now, of course, we could try it with a meter. It's a little bit difficult with the digital multimeter because, because it keeps on auto ranging, and it's just so much easier with a lamp. I think you can see that. Should we do that one more time, just to check that it's? In fact, let's. So I went around that way. Let's go around that way this time. All right. So should be able to spin it both ways, have the same effect. I'm pretty sure we went around the other way before. Let's try this. Lamps off. Lamps on. Okay. So yeah, and hopefully, I don't know how clearly you can hear that, but the centrifugal switch, when it slows down, the centrifugal switch pops back closed. Right, okay. To me, that proves the centrifugal switch is here somewhere. Okay. So now we know that we've got a centrifugal switch here somewhere. We've got a capacitor here somewhere. And so what we need to do, we need to connect AZ possibly to Z and A possibly to T. I say possibly because there would be nothing stopping you from connecting A to Z and AZ to T. And in fact, if the motor doesn't start in the correct direction, that's exactly what we do. I say the correct direction. At the moment I have no particular requirement, but if you were using it for real. Okay, so let's just disconnect this. I mean, of course, we could try this with the battery and the lamp, spinning it up when the motor's on power. I don't think there's really any advantage in doing so for us, because we have seen that I can spin it up fairly quick by hand by using that cord. Okay, so what we're going to do then, we're going to connect the live and neutral up to the main winding, and then we'll also connect Z and T. So my power lead, I lost it for a moment there. Put it somewhere safely, and then promptly forgot where I put it, right in front of me. So live brown. Okay, so we're going to connect the brown to the top left one. Let's see if we can show this. Hopefully you can see this reasonably clearly. There we go. So top left, and in fact it's just going to be easier, to be honest, just looking there. I think that was that one. Yeah, AZ. Okay, so that's where we're going to have live. So we're going to stick live in there, and then also we're going to connect Z. Z is the top of the capacitor. Okay, so let's hook up Z as well. So I can take that block off. Just put that in. Oh, need to open that up first. This is so handy doing these. Okay. And then blue, the neutral, is going to go to A, which is the bottom left one. See if we can find out. There's A. Okay. And then what does that leave us with? We also want T. T. Want to connect T to A. See if we can find that. T. Connect T and A together. Just check we're doing the right ones here. There's 8. That was, if you heard a beep, that was just my multimeter just switching itself off. Okay, so we've done those, and then mustn't forget the ground, mains earth, and S is not required in our case. Okay, let's just have a look why. S is just that midpoint between the start winding and the capacitor. Okay, so we're not going to use S. We've presented S there, but we're not going to use that. Okay, so I reckon that's going to work. That should start up. I'm just going to plug it in. Haven't powered the socket on yet. Obviously, when you do, that's all going to be live, so I'm going to keep my fingers away from there. If you're one of my students, please don't do this at home. I'll get a little bit more tape on there, make a little bit of a flag on there so you can see it spinning, and then hopefully, because we're going to see if we can change direction as well, and it might be a little bit clearer as to what the direction is. Okay, so fingers crossed, when we start this, it should start in a direction. We don't know which direction at the moment. Quite a kick to it, isn't it? You know, it definitely starts with some force. And it's spinning. It's spinning quickly. To my eye, it looks like it's spinning at the same speed as every other 4-pole 50 Hz 1425 RPM motor that I've had. Okay, so that seems to be running just fine. We could of course put a clamp meter around one of those wires and check the current. Might be something we can do in a while. Let's stop that. That's running with the top away from me. So in other words, it's running in, I don't know whether you can see that direction. Okay, and so very, very common requirement. People want to reverse the direction of the motor. Now, by my reckoning, what we can do, instead of going like there and there, what we're going to do, we're just going to connect them like that. We're just going to cross over. Okay, so we're going to remove those like that. Okay, so that's what we're going to do. So T, let's see if we can find T. There's T. I'm going to remove T and swap T with Z. So there's Z. Okay, so I've just swapped those two around. Remember, previously it was going around in that direction. Now I'm expecting it to go around in that direction. Okay. Hopefully it's not going to jump off there. By the way, that's a very heavy steel plate there. Be better off with a bit of a sheet of rubber or something. It would also reduce the vibration. Let's plug it back in. For safety, yeah, I mean, I know that it's a switch socket, but I like to unplug it just to be on the safe side. And you might not be able to make that out, but I could see that was actually now starting in Opposite direction to how it started before. So let's just stop. Okay, and that's proved it. It's now going in that direction. Okay, hopefully that's pretty much covered most things then. So if you've got a motor like this, you could consider that to be the wiring diagram. If the direction is the wrong way round, just remove that link, and then just wire them up like that. Okay, so you could connect a Z to Z and then A to T, but if the motor direction is wrong, then connect a Z to T and A to Z. Now I suppose I should just give you a little warning on that. But of course there's nothing to stop someone from having played around with what goes on what binding post. So really, yeah, get an electrician to do this, and if you're going to risk it yourself, then I suggest that you go through the steps that I went, and maybe some other steps as well, just confirming to yourself that you're quite confident that you know what is actually connected to which binding post. I did say that maybe we get a clamp meter on it, so let's just quickly try that. Just see if I can find a clamp meter. Here we go. Okay, so clamp meter, an old analog one. It's on the 6 amp range at the moment. And so what we could do is that we could try on the run winding. Sorry, I had to think about that for a moment. Okay, or in fact, what we could just do is we can just on the feed there. Okay, just measure the current there. That's just on the live. Okay, and it's a little bit faded here, but I think it possibly says 5.4 amps. That will be the full load current, and I wouldn't expect it to be the full load current because it's not actually got much load on here, just running itself. So I'm going to guess 4 amps or something like that. Having said that, when it starts up, it's going to be many times more than 4 amps, but it should settle down to something like that. So let's start it up. Oh, bang on. And I honestly didn't know that, so that's 4 amps. Okay. Now A to T, let's see if we can identify that. T to AZ. Oh, right, yeah, of course, because we switched them around. Okay, I'm confusing myself there. In fact, what I'm going to do then, I'm just going to switch those back around. Let's switch around T, just so we get it back to how the diagram was originally. And then I won't confuse myself. So I've just disconnected T, and I'm going to disconnect Z, and I'll put that back there. I'll show you the diagram again in a moment. Just I'm probably confusing myself, probably confusing everyone. There we go. Okay, so now I've got Z and AZ together to the live, Z and AZ together on the live, and then T and A together to the neutral. What we got? There we go. T and A connected to neutral. Okay. Now this connects to the to T, and T is the connection to the start winding. So I would have thought that if we put the clamp meter here, we're going to get a brief flicker when there's current drawn by the start winding, and then it's going to go back down to 0. Okay, so let's just try this. Yeah, okay. So no current drawn now because it is the start winding. Pull that plug out. And then if we see what goes to A, let's go on to A. Then I would expect that's going to be the 4 amps while it's running. There we go. Okay. Right, that's it. Hopefully that is as comprehensive as anyone needs. If you've got any comments, I'd really like to hear from you. If you've got any suggestions, if you see anything where I've made a mistake, I'm more than happy to take criticism. I'm not a trained electrician, so you know, anything that I've said here, if you don't feel confident to do the stuff yourself, do get an electrician to do the work for you. Don't rely on my video or what I've said. Okay, thanks very much for watching, and if you think it's useful, please do let me know. Maybe I can record some more videos. Thanks very much then. Bye.